Okay, here's a quick presentation that I want to give on our compounding pharmacies and the idea of pressure being in control or out of control and the acceptance criteria that we have. This is guidance that I'd like to give to the project team, so I'm looking for some feedback and some input on it. First off, picture's worth 1,000 words. So this is 5 days worth of trending in some of our positive pressure rooms from a project. This case, they did 1 minute sampling. So this is 1 minute interval data. Rule number one here is that every time you open a door, you lose pressure. And that's just the way it is. As far as we know, that's okay. There's nothing wrong with that. Rule number two, though, is that there are fluctuations in these systems. This is a control system. It doesn't perfectly nail down a number. So there's always error and fluctuations. And that's also okay as long as it recovers and ultimately stays in control. So here's 5 days worth of trending in the negative pressure room on the same project. And I would love to see those points more closely pulled together. I think we all would. But as a matter of course, as we roll out 100 of these projects across the portfolio, we are going to see charts like this. And so the question that we're here to address today is what is considered acceptable and unacceptable? When is a room or a system considered to be in control and not in control? And so we start off with what does the regulation say, or what does USP 797 say? And it does say words like continuous differential pressure. It does say a pressure differential monitoring system. It does say the results from that monitoring system have to be reviewed and documented. But there's a lot that it doesn't say. We know, for example, that a pressure differential monitoring system can be a piece of paper and a human log that happens once a day. And so it does not clearly say how frequently pressure has to be in range or can be out of range. It doesn't say how long recovery is supposed to take. When a door opens, how long do we have until the system is supposed to recover? And so what is the acceptable deviation that's permitted within that control system over the course of a day or the course of a week? It doesn't describe any of that. And so I believe that's on us to describe that for our projects. And so we took that on close to a year ago at this point. At the end of last year, we tried to take on the idea of defining acceptance criteria for the construction projects. And so we actually nailed down a definition of pressure being in control. And that's written in our HVAC design guideline. We said that 85% of the points that you record should be within control during the day, where we expect more door openings, and that 95% of the points should be within the control range at night, when honestly we expect less door openings. And we defined the response to a door opening event as being 10 seconds. And we're supposed to measure that and show that at the end of the project before we turn it over to pharmacy. So I'll go back to this chart, and I'm actually going to zoom in on 1 day. So here's zooming in on 1 day. Again, in this case, they sampled every minute. And so you have 1440 points. You have your control range 0.01 to 0.03. There was about 40 points that were below that, representing those door opening events and zeroing out the pressure. And then there was another 40 points that were above that, some of them very slightly above that. But a total of 80 points that are out of range, 5% of the points that are out of range. I'm going to argue that this is perfectly acceptable. That is 2 sigma right there. You're at 95% controllability, which is a very good control system. But I think we need to be pretty clear about what are we going to log, what are we going to show. We had a conversation with the team yesterday where we talked about, if we have a pressure monitoring system, that means we're going to be keeping logs in a computer, and we're going to show those logs to the regulator when the regulator walks in. I'm going to suggest that we keep those trend logs every 15 minutes. I don't think there's a benefit to doing 1 minute trends. I think that just creates more points, and you're going to capture more points that are outside the control range. I don't think there's a benefit to doing that just for the regulator's sake. But I also think we should be very clear that if we're keeping trends every 15 minutes, in a 24-hour period, that's about 100 points. And so we are going to see points that are outside of that range. If you have 5 points outside of that range, that's a very good control system. And I'm going to argue that up to 15 points outside of that range are still well within the bounds of acceptability and not cause to shut down the HVAC system or have an alarm. So to talk specifically about alarms, I don't think we want to have an alarm every time we have a point out of range. I think what we do want to alarm is when a system is out of control. So I don't want to see 2 points in a row that are out of range if we're logging every 15 minutes. I think that indicates that now you legitimately have a system that is failing to control or failing to recover. So that would be my recommendation for when we would sound an alarm. We need to alarm if a system fails to recover and fails to recover in a way that compromises the intent of the environmental control. And so what I mean by that is if you lose pressure for a period of time, that compromises the intent of the environmental control. That pressure difference is there for a reason. If you reverse pressure, if a positive room goes negative or a negative room goes positive, that also clearly compromises the intent of that control. Pressure out of range does not necessarily. If you have a room that goes too negative or too positive, there's not necessarily anything about that that's compromising the intent of the control. It's just indicating that your system is out of control. So that's one that I'm going to recommend that we be a little more forgiving on. To be very specific, in a positive pressure room, I'm going to recommend that if you go to 0 for a minute, sound an alarm. If you go negative for a minute, because by the way, there you will see little sort of junk points within this trend log where it went below 0, but some of that's going to be just the margin of error of the sensor. So if you legitimately go negative for a minute, yes, sound the alarm. In a positive pressure room, there's no such thing as too positive. That's not something that's recognized. In one of the negative pressure rooms, though, we do have that rule, and it's a California-specific rule about maintaining the negative pressure within a range. So in a negative pressure room, my recommendation is you go to 0 and you're at 0 for a minute, then we need to sound an alarm. If you go positive and you're positive for a minute, we need to sound an alarm. If you go too negative, then I would want to see a system that is sort of legitimately showing signs of being out of control before we sound an alarm. I don't want to see 2 15-minute logs in a row that show it too negative. And so I would say if we get over 20 minutes, then that's where we'd want to sound an alarm. And that's only on the California systems. In the regions outside of California, we actually don't need to worry about that. So that's actually it. Those are the recommendations. I'd like to give those recommendations to the project teams. Particularly, we have some project teams in flight that could use those recommendations right now. And so I'm looking for feedback. Thanks.